Hey guys, Dr. Brown here, and tonight we're working an integration problem. Square root of x divided by x minus 4, integrated with respect to x. Yeah, what do we do with that one? Okay, let's get after it. Oh, by the way, there's a dog barking outside, so hopefully that won't interfere. And also, I haven't posted in a while. I've been sick again, so I still have a cold. Bear with me. All right. What can we do here? One of our rules, well, what are our rules? We have, let's see, U sub, trig sub, integration by parts, partial fractions, power reduction. What else do we have? Long division and completing the square. Those are the tools that I primarily use. U sub, I don't know, maybe later. Trig sub, no, not now. Integration by parts. I'm thinking partial fractions because I know I can factor this. Now, it might be a little easier if I had a squared term here, but I don't. So that's okay. Let's see. Let's go down this way. Hopefully my sound doesn't drop off. I had a little trouble. All right, so the integral of square root of x divided by the square root of x minus 2, square root x plus 2. Hey. Multiply square root of x times square root of x, I get x. Minus 2 square root of x plus 2 square root of x, those cancel. Negative 2 times positive 2 gives me that negative 4. Okay, dx. Now then, you know, partial fractions, I could say that equals to the integral of a over square root x minus 2 dx plus the integral of b over square root x plus 2 dx. Now I could have just left that integral out, put a big parentheses around it. I'm going to pause and close the window. Hold on just a moment. Okay, hopefully you're still there. All right, I don't know if that's going to be any better. I had to turn a fan on since the window's closed. Okay, let's algebraically set these equal to each other and try to solve for, well, actually get these out of the denominator. So if I were to take square root x divided by square root x minus 2, square root x plus 2, and set that equal to a over square root x minus 2 plus b over square root x plus 2. If I were to multiply both sides by square root x minus 2 over square root x plus 2, square root, may need a little bit more room here so you can see it. Square root x minus 2, square root x plus 2, plus b, that was b over square root x plus 2, times square root x minus 2, square root x plus 2. Now then, you'll notice all of this cancels, except square root x. Okay, in this case, square root x minus 2 cancels. It leaves me with a times square root x plus 2. In this case, square root x plus 2 cancels. It leaves me with b times square root x minus 2. Now I need to solve for a and b. And you know, in your partial fractions, we choose a value of x. Now I have to do this twice, obviously, because I have an a and b term, so I have two variables. I need two equations. So for now, let's let x equal 0. So square root of 0 is 0, and a times 0 plus 2 gives me 2a, right? because I would have 2 inside. 2 times a is 2a. Same situation here, except it's negative, or this is 0. Negative 2 times b gives me minus 2b. If I add 2b to both sides, I have 2b equals 2a. If I divide 2, or both sides by 2, I have b equals a. Okay? Now, another equation. If I can, they call it the cover-up method. If I could figure out how to cover up one of these, I can solve for the other one. If I let x equal 4, square root of 4 is 2. 2 minus 2 is 0. So this one, in effect, would be gone. So let's try this. A square root, I let x equal 4. Square root of 4 is 2. And so a times square root of 4 is 2. 2 plus 2 is 4. That's 4a plus 0, because square root of 4 is 2. 2 minus 2 is 0, so this goes away. 2 equals 4a. Divide both sides by 4. So a equals 1/2. But since a equals b, b is also 1/2. Now then, let's write this up here. A equals 1/2, b equals 1/2. All right, so I'm going to clear out all of this, and we're back to this equation where we can substitute for a and b. All right, so we would have this integral equals 1/2. Now, since we have the constant multiple rule, I can pull that 1/2 to the outside. That's 1/2 times 1 over square root x minus 2 dx plus b, which is 1/2 the integral of 1 over square root x plus 2 dx. So those are my two integrals. So let's work with this one. All right, let's let u now, hey, u sub's coming in there. So u equals square root of x minus 2. So I'm going to go ahead and write that x to the 1/2 minus 2. du then equals, bring down to 1/2, 1/2 x, subtract 1 from this, so 1/2 minus 2 over 2 is minus 1 over 2. And the derivative of 2 is a constant, so chain rule, derivative of x is dx. So let me put this into the denominator. See, well, I'll do it here. du equals 1 over 2 square root x dx. So if I divide both sides by, or excuse me, if I multiply by 2 over square root x to cancel this out, I have 2 square root x du equals dx. Now I still have that square root of x term. What to do about that? Let's go back to this equation where we had u equals square root x minus 2. My writing's not very good tonight. U equals square root of x minus 2. If I were to add 2 to both sides, u plus 2 equals square root of x, negative 2 plus 2, those cancel. U plus 2 equals square root of x. So I have 2 times u plus 2, the parentheses, du, and that equals dx. All right, let's fill in the blanks here. This integral, this one right here, is 1/2 the integral. Remember, square root of x minus 2, that's u. So I have all that over u. It's 1 dx. So dx now is 2 u plus 2 du. Now I'll just go ahead and cancel out the 2 now. So what would this give me if I were to break this in, well, for now let's leave it one integral. U plus 2 over u du. Okay, let's stop there. Now I'm going to erase this back. Well, maybe not. Let me just do on this side. Now, let's work with this side. Same scenario here. Now be careful. You have a -2 and a +2. I'm going to let t equal square root x plus 2. You'll see why in a moment. dt equals, now you're probably thinking, wow, it's the same as this. So that's x to the 1/2, right? So it's 1/2 x to the -1/2. And the derivative of constant 0. Now the chain rule says go back, take the derivative of what's on the inside. That's dx. So that's 1/2, or 1 over square root x dx equals dt. Okay, now then, 2 square root x dt equals dx. Let's go back to what we did earlier. We have t equals square root x plus 2. So that means t minus 2, if I subtract 2 from both sides, equals square root x. So let's plug this in here. I have 2 times t minus 2 dt equals dx. All right, let's go. Recall we're working on this guy here. That's 1/2 the integral of 2t minus 2 dt over square root of x plus 2, which is t. Again, the 2 cancels. I have the integral of t minus 2 over t dt. Now, I'm going to erase back to this. I'm going to keep this value, but I'm going to erase back up to right here. Oh, I should have kept one piece here. I should have kept that u equals square root x minus 2. I'm going to need that. And I'm going to keep this piece right here, down to there. All right, so what's my 2 integrals here? I have the integral, we're in the u world, the integral of u plus 2 over u. So that's u over u, since I have one term in the denominator, plus the integral of 2 over u du, plus the integral of t over t dt, minus the integral of 2 over t dt. All right, so u divided by u is 1. That should be du, not dt, sorry. So the integral of u over u is 1. 1 times du is du. The integral of du is u, plus, I could bring this 2 to the outside. Now I have du, the integral of du over u, which is what? Natural log u. So I have 2 times the natural log of u. Same scenario here. This is 1. The integral of dt is t minus 2 natural log t. I should at this time state something. The first time I worked this, I let u, substituted u, walk through the equation, substituted u, walk through the equation, and I ended up with 2 natural log u minus 2 natural log u. Whoa, those just subtracted out. I kept right on going and got the wrong answer. So be careful. I often separate integrals out so that I can get a clearer picture. And in this case, I didn't utilize a separate variable for the other integral, and it cost me. Okay, I missed it. So be careful with that. All right, so what do we have? Let's now, u is square root of x minus 2. So I have square root of x minus 2 plus 2 natural log of square root x minus 2 plus t, and t is square root x plus 2 minus 2 natural log square root x plus 2. All right, square root of x plus square root of x is 2 square root x. A negative 2 plus 2, those cancel, plus 2 natural log x minus 2 minus 2 natural log square root x plus 2. Now you'll know the rule of logs. If this one's subtracting, I can put those as a quotient. So I end up with 2 square root x plus 2, I'll factor the 2 out, times the natural log of x minus 2 divided by, oh, and that should be square root x plus 2, or minus 2, square root x minus 2 over square root x plus 2, plus c. Square root of x, so I left that one out, sorry. All right, well that, my friend, is the integral results of, we integrated the square root of x over x minus 4 and utilize partial fractions. We end up with 2 square root x plus 2 natural log of the quotient of square root of x minus 2 over square root x plus 2 plus c. Partial fractions. I don't know why, but lately I've been working on that a little bit because there's 4 rules associated with that. There's linear factors, there's repeated linear factors, there's quadratic factors, repeated quadratic factors. And there's a certain form you use for each. So the subsequent videos, I'd like to go through each form and allow you to see how you can utilize it, because this one, I don't know what I would have done with it otherwise. So anyway, why are we doing this? Hey, together we're trying to build a better tomorrow and do that through math. Keep studying, guys, and that's all for now. We'll talk to you next time. Thanks.